Lesson 49, using the binomial theorem. So we're going to start by looking at Pascal's triangle. Have you guys ever heard of Pascal's triangle? Okay, so Pascal's triangle, it's a triangular array of numbers. So the first row is 1, the second row is 1, 1, and it's like offset from the first one. The third row is 1, 2, 1. The fourth row is 1, 3, 3, 1. And the way you find your numbers is you add the two numbers above where the space you want to do. So like right here, the two numbers is 1 and 0, so you put a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 0 is 1. So you're just adding the two numbers above. So 1 plus 0 is 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1 plus 0 is 1. So you just keep going. I'll do one more row. 0 plus 1 is 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. 1 plus 0 is 1. So it looks like a triangle, and it just has all these numbers in it. Now if you look at each row as a number, so the first row is 0, the second row is 1, 2, 3, 4. It's going to be so cool when I tell you this theorem. And then 6. Okay, so these, like if you look at this as the row, so this would be row 4, where you start with row 0. So the binomial theorem says that if you have two numbers raised to a power, you can look at Pascal's triangle at that row. So the a plus b to the 0 power is just 1. And then a plus b to the first power, you use the 1 and 1 as coefficients. So it's going to be 1a plus 1b. And then a plus b squared, you use the coefficients. You have 1 a squared plus 2 a times b plus 1 b squared. So those are your coefficients, 1, 2, 1. Then a plus b cubed is 1 a cubed plus 3 a squared b plus 3 a b squared plus 1 b cubed. So if you notice, the exponent on the a starts with the exponent that's given in your problem, and it goes down. It's descending. So it goes a cubed, a squared, a. And then the b ascends. So this is descending, this one's ascending. So 1, 2, 3. So if we were to do a plus b to the fourth, you would do, look at your fourth row, your coefficients are going to be 1, 4, 6, 4, 1. So you have 1a to the fourth plus 4a cubed b plus 6a squared b squared plus 4a b cubed plus 1b to the fourth. And we'll do just generalizations, the binomial theorem. So this is called the binomial theorem, what we're doing. If you have a plus b to the nth power, you can get these numbers of the Pascal's triangles using combinations. So if you can't remember each of these numbers, you can use a combination. And it's n, or the combination of n items chosen 0 at a time, of a to the nth times b to the 0, plus the combinations of n items chosen 1 at a time. Now remember, n is your exponent. A to the n minus 1 times b to the first, plus the combination of n items chosen 2 at a time, of a to the n minus 2 b squared, plus, and then you continue on all the way until you get to the combination of n items chosen n minus 1 times of a to the first power b to the n minus 1, plus, and your last one would be combinations of n items chosen n at a time, a to the 0, b to the n. Now if you look really carefully, you can see a pattern. You start with the exponent is always on the left, so you always have the n items, and you start with 0, 1, 2, all 3, 4, all the way up to n minus 1 and then n for the number you're choosing. The exponent on a is the difference of these two. So n minus 0, n minus 1, n minus 2, n minus 1, which is 1, and n minus n, which is 0. And then the exponent on b is the second number here. So it's always b to the 0, b to the 1, b to the 2, etc. So there's kind of a pattern there. So I'm going to show you an example. What's really hard is if a and b aren't, if they're numbers or they have numbers and variables, or if it's a minus sign in between instead of a plus. So we have 3x minus 2 to the 4th power. So we're going to plug it into the binomial theorem, and then we'll also look at the Pascal's triangle. So we have 4 items, the combination of 4 items chosen 0 at a time. A is our 3x, so we're going to do 3x, the whole thing, to the 4th power, or 4 minus 0. And then we have negative 2 to the 0 power. Plus, we have the combination of 4 items chosen 1 at a time. A, which is 3x to the 4 minus 1, or cubed. And then negative 2 to the 1st power. Plus the combination of 4 items chosen 2 at a time, 3x squared times negative 2 squared, plus combination of 4 items chosen 3 at a time, times 3x to the 1st power, negative 2 cubed, plus the combinations of 4 items chosen 4 at a time, of 3x to the 0 times negative 2 to the 4th. Now these combinations are just the coefficients that you find up in Pascal's triangle. So if you go up to 4, this combination is 1, this one is 4, the third one is 6, this one's 4, and that one's 1. So you could, if you forget, you can just use it in your calculator, or you can just use the Pascal's triangle. So we have 1 times 3x to the 4th is 81x to the 4th times just 1, plus coefficient here is 4. 3x quantity cubed is 27x cubed times negative 2, plus, and then this combination is 6, so 4 items chosen 2 at a time is 6. 3x squared is 9x squared times 4, plus our coefficient of combination of 4 items chosen 3 at a time is 4. 3x to the 1st power is just 3x. Negative 2 cubed is negative 8, so we'll multiply those together. Plus, and this combination is a 1. 3x to the 0 is 1, and negative 2 to the 4th is a positive 16. Thank you. Then when we multiply these together, we have 81x to the 4th plus, is a negative, sorry, it's a minus 4 times 2 times 27, so minus 216 x cubed. This one's a plus. And this is 6 times 9 times 4, which is the exact same thing, 216 x squared minus 12 times 8, 96 x plus 16. So this is the answer to this problem there. Sometimes you're going to have a problem like this. P plus Q raised to the 10th term. Find the 8th term. So since we want the 8th term, let's see, this was the first, second, third, fourth, fifth. So it's going to be the combination of 10, that's your n, items taken, and it's going to be 7. Remember how we start at 0? So the 8th term is going to have a 7 right there. So the combination of 10 to 7 of p to the 10 minus 7, which is 3, times q to the 7th power. So if you just plug in combination of 10 to 7 in your calculator, you would get 120 p cubed q to the 7th. If you don't have a calculator, can you remember that combinations of 10 to 7 is the 10 factorial over 7 factorial times 3 factorial, which is 10 minus 7. So if you can kind of remember that, that's in case you don't have a calculator figured out. Okay, I have to turn the page because we're going to do another example. Those are all good. Okay, let's say that you flip a coin 5 times. We want to know what's the probability of getting exactly 3 tails. So there is a formula you want to use. It's just C, a combination of m, choose n, p to the n, q to the m minus n. Now I'm going to tell you what everything stands for. So m is the number of trials. In this case, it's going to be 5. N is the number that you want to get, so that's your n. P is the probability of the desired result. Whoops, I don't want to parentheses. It's going to be. So the P is probability of desired. So we want tails, so we want the probability of getting tails. Can't spell result. There we go. And then Q is basically the probability of not P. Those just would be heads. So to solve this problem, we're going to do the combination of 5 items, chosen 3 at a time. P, so we want the probability of tails, which is 1/2, raised to the 3 times 1/2 raised to the 2. So the combination 5 choose 3 is 10 times 1/8 times 1/2. And we can cancel, 1/4, sorry, you have to square that. So we can cancel, make this a 4, make that a 5. So we have 5/16 is a probability that you'll get tails exactly 3 times. I'm going to do one more example. So we're flipping a coin again 5 times. We want the probability of at least 2 tails Okay, so this is different because it could be 2, 3, 4, or 5 tails. So what you want to do is you want to do 1 minus the probability that you get exactly 0 tails, and then minus the probability that you get exactly 1 tail. And then what's left over is that you would get 2 or more tails. So you do 1 minus the combination of 5, choose 0. Probability of getting tails is 1/2 raised to the 0 power times 1/2 raised to the 5 minus 0, or 5. Then minus the combination of 5, choose 1, of 1/2 to the n power, which is 1, times 1/2 to the 5 minus 1, or 4th. So you have 1 minus 1/2 to the 5th is 1/32, minus combination of 5, choose 1 is just 5, times 1/2 basically to the 5th, so 1/32. So let's just do this as 32 over 32 minus 1 minus 5. So 31 minus 5, 26, 32, which reduces to 13/16, and that's the probability of getting at least 2 tails. And that's the end of the lesson.